Hello everyone, welcome to my session. As before start of the tutorial, my first light emitting device simulation, I want to introduce myself. I am Sahil Verma, application engineer of the well-known company Impulse Technology. Our company have partnership with Nano Academics, which is Canada-based company. They offer several software like NanoDecal, Rescue, QTCAT. One of the also well-known company, it is a Matra, which is USA-based company. And one of the where we are performing our tutorial, it is a Fluxim company, which is Switzerland based company. It offers several software like Setfos. I would like move on to next slides. Our services company provide many of the services like software distributor, training program, technical supports. Company also provide equipment like Setprop. Company also have valuable customers like IIT Guwahati, IIT Madras, IIIT Allahabad. For the more detail, you can check our company websites impulsetechnology.in. In the next slides, we will be discussed at here outline. Basically, we are going to study here introduction, block diagram, module description, usage, market size, and application. Before start of tutorial, we should be know about the company. It is Fluxim company with software like Setfos. It is developed by Fluxim company. Fluxim is a Switzerland-based company. It provides simulation software and measurement hardware for the display, lighting, and photovoltaic industry at the worldwide. As the simple word, we can say it is a develop scientific tools that boost your research and development, simulation software upscaling for large area, and measurements hardware for OLEDs, perovskite solar cells, and OP. It is outcome institutes of computational physics, the Zurich University of Applied Science. In 2006, Dr. B. Researcher founded that Fluxim is a spin-off company. They develop several softwares like Setfos, Lois, POIS. We will be discussed at here Setfos software. At the next slides, we will be study about the Setfos because we are performing our tutorial at the Setfos software, so we should be have basic knowledge about the Setfos software. People arise with the question at what is this, so we can explain it here. Simulation software for optical and electrical modeling of the semiconducting device. It is designed for LED solar cells and semiconducting perovskites and quantum dots. At here works fitting and optimization algorithm. Operating system at here Windows 10, Linux, macOS. You can see and updated at here. Multi-threading ensure high-speed computations. So at the one time number of the process occur. So we can say multi-threading ensure high-speed computations. Setfos uses variety of model to simulate optoelectronics, including like dipole emission model, transfer matrix formalism, drift vision module, and my-scatter frames. Optimize the concentration and refractive index of scattering particles basically. Moving at next slide, we will be see graphical user interface. It means where we will be give all of the upper tutorial inputs and visualize our results. Simple word we can say initiative graphical input allowing you to define and manage simulation with a few clicks and visualize results and material data. Graphical user interface show the device design, access the device structures. Multiple simulation can run in parallel, result automatically fastly generated that can be exported different formats. This is fully compatible with Python. At next slide we will be move, so we will be see how is the simulations work. Everybody have questions what is the mechanism. So firstly I will consider one example of OLED and select all desired layer. You can see here when we apply the voltage across OLED, electrons from cathodes and hole from anodes move towards the emissive layer. When excitation pair form, so leading current through the device. When the charge of excitation path is combined, so they will emit light. Now I will move to the next slides. It is a block diagram. Setfos have four different modules to simulate. First is absorption modules, that means capture of the substance and then transform of the energy. Second is distribution modules. Third is emission modules. Fourth is advanced optics modules. Absorption, that have transfer matrix for vision, then calculate photon across the solar cell. That have thin film technology, one of the organic perovskites and inorganic thin film. Calculate number of the parameter like reflectance, transmittance, and couple optoelectrical properties can also be calculated. Now move at the next slides. Distribution modules can be activated by enable of battery lookalike symbol at GUI. Its module help to calculate electrical properties of OLED and solar device like charge concentration, electrical field, recombination zone, short circuit current, open circuit voltage, DC and AC transient analysis. Doping and trapping, that can also be calculated here. Doping help to improve the conductivity of materials and trapping for performance of PV and LED. Excitations, generation, quenching, and contributions roll-off can also be calculated at here. Basically, all of the electrical properties can be calculated at here. Now we will move at next slides. It is emission module. An emission is something that has been emitted, released, or discharged. It uses the dipole emission model to predict light emission characteristics. Set multiple emitters with top to bottoms that help to analysis of emitted vs radiated powers. Number of the characteristics of the emission properties we can calculate it at here. So now we will move at the next slides. Advanced scatterings. Scattering means direction of motion of particles change because of collision with another particles. That means 80% of emitted light in OLED trapped inside the organic substrate layers. This module helps to design a scattering layer with the optimized OLED efficiency. At simple word we can say it is a process to direction of motion of particles and radiation change randomly as they pass through the mediums. Now we will move at the next slides. Number of the Setfos users given at here. Setfos is a simulation software used to model and analyze the optical and electrical properties of semiconducting devices like solar cell and LEDs. It also supports model for mobile ionic charge with hysteresis effects. New feature updates regularly at here. Local and support from main developer can be provided. Can simulate quantum dot solar cell with nanoparticles effects. It also supports unlimited semiconducting layer with device modeling and simulations. At simulations, material property database, graphical user interface, you can study at here and use as per your choices. Now we will move at the next slides. It will be a market size. If someone working on that fields, they want some benefits. So at mention at here market size of the global perovskite solar cells and global solar cells, both are the gear. So you can see it here. One of the international conference also occurs. So now we will move at the next slides. It will be a Setfos applications. We mention number of Setfos application. You can study here one by one as one of the organic photodetector, quantum dot solar cell, organic light emitting diode, perovskite, OLED, white OLED, polymer, LED blue, like this. As now I'm going to start up my tutorial, my first light emitting device simulations. So now I will be open Setfos 5.5 software tool for performing our tutorials. At here mentions all of the new features which is given by Setfos 5.54 versions. At here new topic model also introduced. So it is a geographical user interface of the Setfos. At the above side, it all of the Setfos toolbar. It is a workspace where library given. It is a simulation view where all of the input you will be provided and desired result you can see at here. Layer structure and energy level diagram you can see at here right sides. At the first tool, it will be used for create new simulation files. At it will be existing the simulation files. At the next, where we save the simulations files. At the save as, it will be current simulation that we occur can save here. At the number of results can exist here. At the eye look like symbol for the passive optics, that yellow sun-like symbol, it is used for absorption modules activations. So we can calculate absorption parameters. At battery look like symbol used for depth vision modules, and the bulb-like symbols used for emission properties. All the emission characteristics we can calculate it here. It is a advanced optics modules, also known as light scattering modules. It is a master equations that used for the define material specific excitation parameters. They are task mode buttons, shift mode for enable multivariable shifts, and optimization mode for optimization analysis for best effective results, and the fit emission zone for the emissive calculation we can use that parameters. You can give name here at your simulations file. It is a abort simulation for stop the simulations. It is a run for the play buttons. It is a graphical inputs. It is a script editor modes. It is a output consoles. It is a symbol for results. At here layer structure is given at the simulation view. So that is a layer you want, so you can give the name here at the below sides. If you activate that modules, so you can see at here as like absorption settings will be on at here. So at one by one you can give name here at the mention at here thickness. It is a units of the thickness, and as you press at the green symbols, so new layer that can be added here. Now we will be give the name one by one as per our tutorials. New simulations layer stack will come from click at create new simulation file. Now I will give here layer name one by one as ITO, PEDOT, polymers, calcium. You can add more layer through plus sign. You can also add interface if you want. Now I will fill that column thickness. I will consider here 10 mm thickness. Top and bottom layer are semi-infinite media, so thickness are always irrelevant here. At here layer structure are completed. Now you will be imported refractive index of the layer. That material show refractive index, so we will be imports here as ITO. We will be choose at tabular test file is NK format. So ITO.nk, we will be select that file and save here. At the similar we will do with polymer. File tabulated.nk formats and import that file. And the choose pfo.nk. At the similar we will be consider as aluminum and import that file air.nk and press open and save here. At product refractive index mentioned at 1.5. At the similar we will be consider as calcium. We should be notice at here we mention define constant refractive index of the material that do not show any dispersion. So therefore we will be mention at here PEDOT and calcium respectively. As calcium, consider refractive index is 0.75 and the K will be chosen at 2.2. To perform emission calculation, we need to activate emission mode, click at bulb tool and polymer layer consider as emitter. We will import the file at the .pl format. We will choose a do image pv.pl. At below sides we choose distribution which delta and the position we will be considered at here 0.5 as your tutorial mentions already. At above the file you import, it is a photoluminescence spectrum file. It is typically indexed with .pl file formats. It is a emission settings. If you click, you can see at here wavelength ranges that vary from 380 to 780. In here, emission settings, it will must be a transparent. So polymer will be enable at transparent. Now you will give the name of simulation file. Now you will be give name the simulations, my first light emitting device simulation, and run the simulations. You have defined all of the layers, so now run simulations. You can see at here results. It is a color diagram. It is a optical profiles mentioned here, and the spectral emissions at the above side spectrals. They give the names with lines. All of the designs you can mention at here. That's you want. It is a color. If you want to change the parameters, so you can click at the right sides. It will make at the emissions at the y-axis and wavelength at the x-axis. Similarly at here, through the y-axis you can change at the grid log axis. You can enable it through the click. In this tutorial, Setfos calculate outcoupling into the glass layer on top of stack layer. If we calculate in order outcouple light into air, we have to introduce additional layer on top of stacks. So I will be giving name here at air and thickness will consider 100 nm. It will be taken as constant because it is a top of layer. At the next we will be give the name subtract layer. At the layer structures will be changed with the thickness. At the above the thickness 500 nm you will be consider discretization elements at 100 because it will be reduce the amount of data which can improve performance for whole extraction. Now you will be run at the simulations. At the result view you can see all of the results that mentioned at here. Spectral emissions, optical profiles you can check at here. Emitted and intrinsic you can check. So now our first light emitting device simulations as first tutorial have completed here. Now if you want to compare two simulation scripts, you can compare at here. At the example profiles you can compare. You will be click control button and hold it, then select the corresponding files. We compare head outcoupling with glass layer on top stacks with light into airs. So now you can see it here, normalized emissions at through the right side of the Setfos. All of the parameters given at below sides. Normalized emissions. If you want to change the range, you can also change at heads as given x-axis and y-axis. I hope you like my tutorial. If you have any doubts, drop a comment or you can contact me through my emails given at description box. You can check my websites impulsetechnology.in.